So hello everyone, in this video we'll be solving another LeetCode problem and the problem name is Count Special Triplets. So you are given an integer array nums. A special triplet is defined as triplet of indices I, j and k such that I, j and k is between the range of the array and I is less than j is less than k. That means k should be the greatest, then j and then I. They should be strictly greater, not equal to I as well. And then they have said that n is nothing but the num's length, so we can say that the valid range is 0 till n minus 1 for these I, j and k. And what is the second and third condition? Nums of j times 2 should be equals to nums of I and nums of k. That means whatever nums of j you choose, if you multiply it by 2, that should be equal to your nums of I and nums of k. So you need to find such j. So in total you need to return how many total special triplets can be formed using this I, j and k. And since the answer can be very large, so you just need to return the answer with mod value of 199 plus 7. So it can happen that your answer can go out of the integer range, so you just need to return with this mod. So this is easy to understand problem. You just need to fulfill the criteria the question has just told, these three things, and you just need to return how many such indices or such triplets are possible which follows this condition. So it is easy. We can just understand with the help of this first example. So the first example is this 8 4 2 8 4. So one way is that you can just run 3 loops, one for I, one for j and one for k, which fulfills these conditions that the question has said. But if you look at the constraints, if you just run a loop for 3 times, it will just give you TLE. So we need to do some kind of pre-computation and we need to keep track of the element. So in this kind of scenario, what we can do, we can just keep an unordered map which can keep track of what all elements are with us previously and what all elements which will be having in the future. So in this kind of question we use such techniques. So what we can do, we can already process elements, because actually what we need to find for this particular nums of j, this is nums of j, we need to find elements for nums of k which will be in the future, and we need to find element nums of I which will be in the past. So for this we can keep the 2 unordered maps which will keep track of one for the right elements which will be occurring in the future and one which is on the left which are already occurred in the past. So what we can do, I can just show you with the dry run of how we'll be solving this problem. So initially you can say that okay, all the elements will be in the right because we haven't processed anything, so everything will be processed in the future. So we can keep a right map which will keep all the elements currently. Now this will be the map, so I can just give a key value pair of thing. So let me just draw this. So right will be having 8 4 2. So 2 is coming 1 number of time, 4 is coming 2 number of time, and 8 is coming 2 number of time. And initially this will be the left array, which left map which will be empty initially because we haven't processed anything till now. So first we come out to this element. This will be, we are processing for the jth index. So we are at this particular position. So how we need to check how many elements are there to the right and how many elements are there on the left which would fulfill this condition which we have just seen in the question. So first what we need to do, we need to just remove this element from the right. Why we need to remove? Because we are currently at this position. So this element is no more in the right side. We are at this position. So we need to first remove this element from the right. So okay, we removed it, and then we need to check, we need to calculate a value temp which will be nothing but this nums of j multiplied by 2, and this value we need to find if there are any values in left array and left map and right map or not. So we can find that left one is empty, so for the left part we'll be getting 0, and for the right part, what is j? J is 8 multiplied by 2 is 16. So there is nothing element 16 in the right, so right is also 0. So for this element we won't find any two elements or two indices I and k. So for this our answer remains 0. Now we can move on to the next element, but before moving on to the next element we first need to keep this element inside the left array, because we will now be at this index, so this will be coming inside the left part. So we just need to, we have already removed it from the right, we just need to like fit this element inside the left array. So now we are at this particular index I. We can keep track of our answer, which is currently 0, and we will update as soon as we get valid answers or valid indices or valid triplets, you can say. So we are at this particular index now, which is 4. So first we need to remove this element from the right part, because we are at this particular element, so it is not towards the right, not towards the left, we are at this position. So that's why we will first remove this element. Now we will be calculating the temp value, which will be nothing but nums of j multiplied by 2. So here it is 4 multiplied by 2, which is 8. So we will check how many elements are present inside our left and right maps which has this value 8. So for the right part we can say okay, there is one element. In the left part we can say okay, there is one element. So how many combinations can be possible? Left multiplied by right. So that's why we are multiplying, because we need to try out each and every combination. So 1 multiplied by 1, we will get 1. So we can just increment our answer, because we found valid triplet for this I, j and k. J is nothing but this element, I is nothing but element from the left, and k is nothing but element from the right. So we found one triplet, so we'll increment our answer by 1. Then we will move out to this next index, that is 2. Next element, which is 2. So before that we need to like fit this element 4 inside the left part. So we'll just move element 4 to the left, and then we'll continue our iteration. Now we are currently at this index which has the element 2. So first we need to remove this from our right part. So this index, this frequency will become 0. We'll then calculate the temporary value, which will be nothing but nums of j multiplied by 2, which is nothing but 2 cross 2, which is equal to 4. So we need to find, are there any elements existing inside the right and left which has the value 4? Yes, we can find. This is 1 and this is 1. So in this case also we'll be multiplying 1 by 1, and we'll be getting our total number of combinations to be 1. So we can say that okay, we again found one triplet with j having the value nums of j to be 2 and 1 to be 4 and 1 to be 4. So we found 4, 2, 4, again one valid triplet. These are the nums value, not the indices. You can take indices as well. So we found another triplet, so we will increment our answer by 1. Then we'll be moving to this particular index which has the element 8. But before that we need to keep true inside our left part. So we just push it inside our map. Then we need to process this element 8. Now first we need to remove this frequency from the right part, and then we will process it. So first we'll be calculating temp value. Temp value is nothing but nums of j multiplied by 2. So here again it will be 16, and there is no 16 inside our right and the left part. So our answer won't change here. So answer is still remaining 2 only. Then we will be coming on to this 4. Now before moving on to the 4, we just need to push this 8 inside our left part. So pushing means incrementing the frequency by 1. So here 8's frequency will become 2. So we are currently at 4. So first we will be removing this 4 from the right part, so it will become 0, and then we will calculate the temporary value. Temporary value will be nothing but nums of j multiplied by 2, that is 8. Now are there any elements having 8 in the right part as well as in the left part or not? In right we have 8 frequency 0, so there is no 8 element present in the right, and that doesn't make any sense to check in the left, because if there is no in the right, so even if it is in the left it won't make a difference, because multiplying by 0 with anything will result in 0. So for this combination we won't find anything, so our answer still remains 2. So we have processed all the elements, so our final answer is 2, so we'll be returning 2. So you can see that our output is also 2. So this is how we'll be solving this problem. Let us understand with the code for better understanding. With the code you will be having a better idea how these things actually work. So let us see the code now. So yeah, this is the code. So I have declared one mod value which is 1a9 plus 7 because we need to take care of the mod as well, so that our answer remains inside the integer range. So I have declared two unordered maps, left and right. Now why I have declared unordered map? Because here we don't need to keep track of order of the element, so we can just take an unordered map. Left will be having all the elements which are processed in the past. Right will be containing all the elements that we have in the future. So first everything will be inside the right part because every element will be in the future. We haven't processed anything yet. So initially all the elements will be in the right. Then we have declared answer variable and n as the size of the nums array. Then we are doing this thing again and again for each and every element. So first we are removing that ith element from our right part. So this is not actually ith, this is actually the jth element. I have just taken just changed the variable name. This is actually the jth element. So yeah, this is the one change that I have done in the code. So in explanation part I have said that this is j and this is actually the jth element only, but yeah, just in the code I have taken changed the variable name to I. Everything else is working fine, same only. So first what we'll do, we'll remove this ith element from the right part. Why? Because this current element is not to the right and not to the left. It is the current element. With this element we need to find what is in the right and what is in the left. So that's why we need to first remove this element from the right part. Then we will calculate this temporary value, which is nothing but nums of I multiplied by 2. Then we will check if this temp exists in both left part and right part or not. If it exists, how many combinations can be possible? Frequency of left frequency and right frequency, their multiplication. Why? Because we'll be trying out each and every possible combination with each and every number. So that's why we are multiplying it. So our answer would be nothing but left multiplied by right, or like frequency of left for this temp value or frequency of right for this temp value. We are multiplying it, we are taking care of the mod, and we are adding it to our answer. Now before going on to the next element, this current element that we have, if this current element we have processed it, now we are going on to this index. So this particular element should go on to the left part. So we are just adding this element or increasing its frequency in the left unordered map. So yeah, this process will continue for each and every number. In the end we are just returning the answer that we are getting. So I hope you understand this solution. Thank you for watching.